Dependency injection in Blazor is a mechanism that makes application-wide services available to components. The standard services provided in a Blazor project demonstrate the concept, providing an HTTP client, an interface to the browser's JavaScript runtime, as well as URI helper functionality. You can add your own services and inject them into components as required. The upcoming demo shows how to utilize the HTTP client for data access purposes and how to create your own data layer service to separate the implementation from the components that use it. I've created a new demo project with an empty page component called Country Table HTTP Client. I have access to a data service that returns basic country data in JSON format, and I'll use this to retrieve the information. For a start, I add some Blazor code that assumes the existence of a collection called countries and shows the content of that collection in a table. I add an @code block with the countries property. I'll introduce the type country in a moment. Now I add an override of the method onInitializedAsync. This method is called by Blazor when the component is being initialized. I include a variable to store the URL I'll use to access the data. I need access to the standard service HTTP client, which is supplied by the Blazor Dependency Injection system. Near the top of the file, I add an @inject directive to retrieve the HTTP client reference. The first parameter is the type of the service I need. The second parameter is the name of a property in this component that will receive the service reference. Note that I don't need to create this property myself since I'm working in a Blazor component. Blazor does this automatically. The auto-generated property is decorated with the inject attribute. If I implement a component in C# without Blazor, I can retrieve injected services by adding the same decorated property manually. The HTTP client has several methods that support different HTTP verbs. All these use the browser's fetch API. It can also work with JSON directly, using an embedded library with basic functionality. For complex cases, you may need to include a more powerful JSON library in your project. I'll use the standard functionality in this demo. I bring up the data URL in the browser, and you can see that the structure has a top-level element called data, which holds the list of country details. To automate the deserialization of this JSON data, I need to create an equivalent class structure. I add a class called data to the project. Note that the property name reflects the name of the JSON element exactly. Simple JSON supports automatic case conversion of property names, but for this demo, it's more convenient to work directly with the JavaScript names. I'll explain the case conversion feature in more detail in an upcoming video. Back in the Blazor component, I can now add the code to retrieve the data, which automatically creates instances of the classes I created. I retrieve the resulting collection of country objects and store it in my component property. I run the application. In the browser, you can see that the placeholder text is displayed for a short period of time before it is replaced by the data table. The state change is detected automatically by Blazor when the task returned by onInitializedAsync finishes its work. For the second part of the demo, I'll implement a custom data layer service. I begin by adding a class data layer that implements an interface iDataLayer. An instance of this class will be created by the dependency injection mechanism when I register it in a moment. To implement the fetch countries method, I need access to the HTTP client service as before. Since the class I'm implementing is not a component, I can't use the inject attribute to retrieve that service reference. Instead, I need to use constructor injection in this case. I add some using statements and a constructor that stores the reference to the HTTP client service for later use. Now I can implement fetch countries. The code is similar to that I used previously, only the URL is created to incorporate the method parameters using string interpolation. To register my service with the Blazor Dependency Injection system, I edit the file startup.cs in the project. I add a line in Configure Services to set up my service as a singleton. At this time, Blazor supports singletons and transient service instances. For singletons, one instance handles all calls. Transient instances are created each time a service is requested. For complex scenarios, there are several other overloads of the configuration methods on the iServiceCollection interface. In this case, I use an overload that auto-creates a single instance of the type data layer and satisfies requests for the iDataLayer service using that instance. Now I edit the country table data layer component. For a start, I add code similar to that for the HTTP client sample. The @inject directive now retrieves a reference to my custom service, and the implementation of load data uses the fetch countries method of the data layer to retrieve the data. I build and reload, and the new component shows the same data as the old one did. To make the implementation a bit more realistic, I want to add some functionality that takes advantage of the data layer's ability to change the sort order dynamically. I add properties to store the current sort order. I change the load data implementation to use these values when calling fetch countries. I create an event handler method that changes these values when a column header is clicked and reloads data. I add on-click event handlers to the 3 column headers for the country data. Each of these calls into the header click handler, passing in the name of the data field represented by the column. Finally, I change the header at the top to reflect the current sort order correctly. I build and reload again. Now I can click the column headers and the sort field and direction changes as expected. As a final usability enhancement, I implement a component called Sort Indicator. This uses an icon to show an arrow indicating the sort direction based on parameters. Back in the table implementation, I need to include the sort indicator in each data column header. That part of the markup is already getting complex and somewhat repetitive, so I add a Razor template to create the column headers. This template has 2 parameters for the field name and caption, and it generates the th element, including the on-click event handler and the sort indicator. The caption is cast to the type markup string, which renders the content of that parameter as pure HTML to support the second column header, which uses superscript. Finally, I replace the column header items with calls to the new Razor template. This completes the sample implementation. I build and reload again, and the functionality works correctly at runtime. I change the sort order, and the indicator displays its arrows as expected. That's it for this video. Make sure to keep up to date with all of our YouTube content by subscribing and ringing the bell. Thanks for watching.